Okay, so in this video we're going to go through ionic bonding. If you're not comfortable with drawing the atoms and ions, before you start this video I'll go back to the previous video which goes through drawing atoms and ions, which will help you massively drawing these because you have to draw atoms and ions to draw ionic bonding. So if you're comfortable and you're going to start this video, can we get a periodic table please and a piece of paper to write any of your answers to the questions on. First of all, starting with the fact I've written NaCl in the corner, that's because we're going to draw NaCl ionic bond out. So first thing we're going to do is we're going to draw the atom, just as we did before. Only difference is I'm going to draw Na with dots to represent the electrons, and that will be really clear and show really clearly what's happening during ionic bonding later when we've got the full ionic bond drawn. So 2 in the first shell, 8. That gives us 10. There's only 11, so that outer shell Na is going to have 1 electron on its own. Cl's got 17, so I'm going to draw Cl with 2 in the first shell, 2 crosses, like I said, show the different elements here. I'm drawing with different things. 2 in the first, 8 in the next, and the final shell is going to have the 7 to make up to 17. Now, drawing an arrow to show these two things react together. When they react together, we form the ions. So we're going to draw the ions like we did the other day. So Na is going to lose 1 because atoms always want to have a full outer shell. So for Na to have a full outer shell, it's going to lose 1. So I'm going to draw in the first shell, still got the same number. Second shell has got 8, still full. And the outer one is going to be lost. It's going to be donated elsewhere. So I can quite happily say this is the drawing of the ion, square brackets round with a +1. Cl, exactly the same. 2 in the first, second shell is going to be the same. It wants to have a full outer shell, and at the minute this one's 1 missing for the full outer shell, so it's going to gain 1. And that extra one is going to come from the Na atom. So draw the 7 electrons out, and then I've drawn this dot here. And that dot's showing it's actually come from that Na. The Na's donated 1, Cl's gained 1. I'm going to just put some square brackets around. It's going to be a negative 1 because it's gained 1. Now, what's happened then for this ionic bonding to happen is Na has lost 1 electron and Cl has gained 1 electron. You can see that in the diagram. Na from there to there has lost 1, and Cl from this diagram of the atom to the ion has gained 1. Now, what makes it ionic bonding and not just 2 ions is because there's a positive one, that should be, and a negative one, and that causes something called electrostatic attraction. Electrostatic attraction, big fancy word, and all it means is it's saying that there's a positive and a negative that are pulling the two things together. So all it's saying is that these two things are attracted to each other, they're going to stay to each other because of this positive and negative. So just reviewing ionic bonding, what we've done, all we've done is 2 things different. We started by drawing the atoms, which we did in the last video. We've drawn the ions, which we did in the last video. 2 things differently is one of them was drawn with dots rather than crosses, just to show that change and where the movement of electrons had happened. Other thing that's changed is the electrostatic attraction. New word that we've looked at. All it means is that the positive and negative are pulled together, or they're pushed together, causing a bond. Now you've had a chance to listen to me explaining how we draw the ionic bonds for NaCl. Pause the video and have a go for these 3, drawing the ionic bonds for each of them. Remembering, draw 1 with dots and 1 with crosses, just to show that transfer of electrons, the movement of those electrons. Okay, so now you've had a chance to draw them out yourselves. I'm going to go through the first one and then put the other 2 up for you to mark. If you've got another colour pen, it'd be useful to see what you've done well and what you haven't. If not, it doesn't matter. So potassium has got 19 electrons, so we're going to draw the atoms to start with. So first of all, 2 in the first shell, in the second, 8, it's maximum, remember. Third shell, it's going to be also maximum, that gives us up to 18. I've just said it's got 19, so therefore final shell would just have 1 electron. Then we're going to do fluorine. I'm going to do fluorine with dots just to make sure that we see the change in electrons or the movement of electrons. So 2 in the first one, 2 dots in the first. That second shell is going to have 7, which gives us up to the 9 electrons which fluorine has. Draw an arrow to show that there's a chemical change happening. These two things are reacting together. I'm going to draw the ions out. So this one's going to lose that 1 electron because it wants a full outer shell, and this one wants to gain 1 to be a full outer shell. Drawing the square brackets, going to put inside. First shell's full, second shell is full, third shell is full. Because it's going to have lost that outer electron in the outer shells, it's only now got 3 shells and it's got a positive charge. And then draw the fluorine ion, so that's going to have still 2 in the first, it's going to have 7 dots, and it's going to have gained an electron. So 1 cross. Put my square brackets, that's going to be a -1 because it's going to have gained 1 electron. And between the positive and negative, there is the electrostatic attraction. So what we did is we drew the atom for potassium, atom for fluorine, drew the ions out, made sure that it was really clear the electron transfer, that the potassium had gone to the oxygen, the potassium had gone to the fluorine, like here, it's gained 1, by drawing 1 as dots and 1 as crosses. Doesn't matter which way around you do it, as long as you've shown that change. Electrostatic attraction, attraction between the positive and negative. So I've just added the other answers. Magnesium 2 the first, 8 and then 2, becomes 2 and then 8 with a +2 charge. Oxygen 2 and then 6 becomes 2 and 8 with a 2- charge. Calcium 2, 8, 8, 2 becomes 2, 8, 8 with a +2 charge. Sulfur 2, 8, 6 becomes 2, 8, 8 with a 2- charge. So a common 5-mark question in exam papers is this one here, and it's all about ionic bonding, which is why I think it's really important that we go through it. So figure 3 shows the transfer of electrons during the reaction. Describe what happens when potassium reacts with fluorine to produce potassium fluoride. Write about electron transfer in your answer. So what we've got is we've got potassium with 1 electron in its outer shell. It's only shown the outer shells, which it often does in the exams. So you've got potassium with 1 electron in its outer shell, fluorine with 7, and then it shows that actually once they've reacted together, you've got potassium with no electrons in that outer shell because we're not drawing any of the other shells, and a positive charge, and fluorine has gained that electron. The dot's now there, it's not on the potassium, and there's a negative charge overall. As I said earlier, between these two there's a type of attraction, which is an electrostatic attraction. So if I were to write the answer to this, you need 5 points, and I would write it as bullet points, so I'm going to write it in purple to make it clear this is what I'm writing. I would write potassium donates 1 electron or loses 1 electron, it's up to you. I would then make the second point of fluorine gains 1 electron. I'd then talk about the charges on both, so I would say potassium becomes a +1 charge. Same again for fluorine, so fluorine becomes a -1 charge. Now, what's really important to look at is I've got 4 marks there, and I've taken all 4 of those marks off this diagram here. So figure 3 has given me 4 marks. By spotting the difference between the start and potassium's actually lost 1, fluorine's gained 1, and there's a positive here and there's a negative there, you can get the 4 marks. The 5th mark comes from that type of attraction that I keep talking about between these ions, and that is the electrostatic attraction. That would give you your full 5 marks. So first mark, telling me what happens to potassium. Second mark, what happens to fluorine's electrons. And then potassium becomes a positive charge, fluorine becomes a negative charge, and the electrostatic attraction between the two. Okay, so now that we've gone through an exam question, I've just changed the chemicals, which is what usually happens year on year for each exam. They changed which elements reacting together. So what I'd like you to have a go is with magnesium and oxygen, and go through the same marking points: what happens to magnesium electrons, what happens to oxygen atoms, and then what is formed each one. Simply write it down, tell what type of attraction. Pause the video now, have a go, and we'll mark it in a moment. So now you've had a chance to have a go at it. First marking point would be magnesium donates 2 electrons, so I'm just going to write Mg, donates 2 electrons. Oxygen, well, that's going to gain 2. You can see it's got 2 extra here, so oxygen gains 2 electrons. What does Mg become? It becomes an Mg2 plus ion. Oxygen becomes a 2 minus ion, and that's all in the question. It tells you what type of ion it becomes. You do not need to be able to tell me. And then finally, this is the piece of information you need to remember: the type of attraction between the two is electrostatic attraction. That would give you all 5 marks. So mark yours. Have you got those 5 things in it? If not, add it in and make sure you remember next time.